Hi, Josh.
Hi,
Um,
Phil. Nice to see you again.
Hi, good to see you. So we're going to continue our series of short videos about AI and about its use in market research. And today I want to talk to you about the use of large language models such as ChatGPT and others for analyzing market research data. Yeah, let's talk first of all about text analysis. So there's obviously lots of tools commercially available that take a large volume of verbatim data, for example, from surveys or social media data or customer feedback data, and summarize those data into a code frame so that different themes can be identified and quantitatively sized. Could you just start by giving a little explainer about how that works, how AI is used to auto code in text analysis?
Yeah, for sure. At least traditionally, machine learning has been used for the coding of verbatims, typically in what's called supervised learning. So, in supervised learning, basically what's provided to the model are many, many, many examples that have been labeled according to a certain code in this example. So, basically, it requires many, like it could be, let's say, thousands of examples for each type of label that you want the model to be able to accurately predict. And if you've given it that many examples, then it could use a few different techniques, but usually it uses what are called sentence embeddings or word embeddings to provide some sort of representation of the different texts that you're providing. And then when you give it a new example, it's sort of just looking at, for a certain label that you provided, all of the examples that you gave and finding what's sort of the closest nearest neighbor or something to that effect for the new example that you're trying to predict. So that's called supervised learning, where you're giving many, many labeled examples and then trying to get the model to predict the same labels for new classes, for new examples.
Mm-hmm.
So one of the big limitations there is that you're not able to easily give it new labels that maybe you don't have thousands of examples for. And another approach is unsupervised methods. So for example, clustering is a typical example of an unsupervised method. And in this case, you don't need to necessarily give it labeled examples. But on the other hand, you don't have as much control. So in an unsupervised method, such as clustering, you might get, let's say, useful clusters at the end, but they might not necessarily correspond to the exact types of things that you're interested in as a researcher.
So I suppose there's some issues that need to be overcome if you're using a large language model for text analysis. I assume it can't be used out of the box, and there's some training that needs to be done to create a code frame that's going to be most useful and most actionable for market research purposes. So, assuming that's the case, can you tell me something about what those issues are and how they can be overcome?
Yeah, so one of the really cool things actually about large language models is that sometimes they can just do it really well out of the box. And so this is because of one of their capacities for what's known as zero shot or few shot learning, where in certain cases, if you give it even zero examples or one example, or let's say three examples, it could be able to do classification pretty reliably. So this really depends on the particular task, or let's say the particular code frame that you're dealing with. So if you're looking at a small number of codes, and they're pretty sort of semantically distinct, then you might just be able to tell something like GPT, like say, here's the list of verbatims that I have. Here's a small list of labels that I want you to assign to it. Go ahead and do it, and it will be able to do it
Okay.
pretty reliably, which is really cool. Where, of course, it gets more difficult is if you have a large number of codes, and maybe there's semantically complex distinctions. And in a sense, this is pretty typical for humans as well. If you give a human a huge list of labels and they're all some of them are really close to each other, and then you tell them to label a huge data set, that's going to be pretty tricky. So in a sense, it's no different for the AI. In particular, if there's a lot of edge cases, then you might run into a lot of complications there. If you have multiple codes that are sort of really close to each other in a sense, like maybe the labels for those codes share some of the same words, but there's a nuanced difference, then that's where it's going to get quite complicated. And so there's sort of a number of different approaches to this. You could, depending on what kind of what your exact problem is. So for example, if you're doing a tracking study, then maybe you already have quite a bit of data. And so you could use those training examples sort of in the same way that you would have used it for supervised learning, but maybe now you need less. But in other cases, maybe it's more a question of having some sort of human AI interface where the AI is actually able to actively help the human to almost come up with better labels that are more amenable to a large language model being able to classify them. And so what you end up with, in a sense, is kind of no different from traditional analytical problems, where you want a mixture of expertise, and in a sense, some of the experts are more expensive. So maybe you have you might even be wanting to combine different types of language models. Maybe some are really expensive for the really hard tasks, and some are cheaper. And so you want to kind of use an ideal mixture of those in order to keep costs down. And actually, in an upcoming publication that we're working on here at Next Intelligence, we actually show that for certain tasks, there actually is sort of a pretty strong cost benefit to using much cheaper models, where something like GPT-3 might be really overkill. But in other scenarios, you might want to use GPT-3 because even with tons and tons of annotation examples, supervised learning methods might not be able to perform as well as GPT.